long ago, they were clumped together. It meant something started them moving. The universe had a beginning. Today, it's called the Big Bang Theory. First, the universe was a bright, hot point, smaller than an atom. In the mother of all explosions, it started expanding. Eventually, the hydrogen gas in space cooled down and began to form stars and galaxies of stars. Galaxies flying outward, surfing along on the expansion of space itself. So now we can calculate the age of the universe. It's the kind of mathematics you do on a motor trip. If your speed is 30 miles an hour and you've traveled 60 miles, you can figure you've been traveling for 2 hours. The red shift tells us the speed of stars, and the milestone Cepheid stars tell us how far they've traveled. When astronomers divide it out, it says the Big Bang happened 15 to 20 billion years ago. Long ago and far away. So who cares?
Well, we're answering one of the most fundamental questions that human beings can pose, and that is, how old is the universe that we live in? How did it begin? And what's its evolution? Those are major questions. Those are major philosophical questions, questions that religions have touched on, philosophy has touched on, physics is touching on, mathematics is touching on. And the people who are eventually going to come up with what is going to be accepted to be the right answer will make history of a kind. They will have contributed significantly to human knowledge. That, I think, is why it's such an important set of questions.
And there's been a growing sense, as the millennium approaches its end, that the right answer is on the tip of our tongues, so to speak. But not yet, not quite. Today's stargazers usually head for the hills. Hawaii's Mauna Kea, the Chilean Andes, Arizona's Mount Hopkins. Robert Kirshner works 8,500 feet up, hunting dying stars.
I really like coming to the mountain. I like getting away from all the 100 distractions that you have when you're busy, and people are coming in to see you about all kinds of things, and the makeup exam and all that kind of stuff. And to just concentrate for a couple of days only on the scientific investigation, only on what you're trying to do, it's very, very good.
Light pollution has chased astronomers out of the cities to lonely vigils in remote locations. Kirshner watches for the sudden flare-up that means a star has exploded, a supernova, or its smaller cousin, a nova.
The kinds of things I'm working on, these supernovae, which are events that come and go, if you don't get it this year or this month, that one is gone. You just lose the chance.
A supernova suddenly outshines its entire galaxy for a few weeks. If Kirshner and his colleagues can calibrate these cosmic flashbulbs, supernovas may prove even better mileposts than Cepheids.
The game now for the supernovae, I think, is to find distant ones and to see if they really are the same as the nearby ones. Then we'll have a reliable tool to map out large-scale structure in the universe, and the supernovae, the Type 1 supernovae, look to me like a really good candidate for that.
It's easy to find where supernovas have been. There are clouds of dust and gas in space marking places where stars have blown up. But supernovas are rare. A galaxy of 100 million stars might have one exploding star every 100 years. So Kirshner watches and waits.
Well, the heroic age of observing has really passed. It used to be that you would be outside the whole night long, instead of sitting in a control room where a television brings the signal in and you're operating on a computer keyboard.
24,
okay,
CCD in the right mode.
It's hard staying up all night.
Good.
But there's a kind of sense of adventure to it that is a little bit like being a kid and lying out in the snow and kind of figuring out the constellations. Some of that is good for you, too.
Yeah, fine. Breaking in the cookies already.
Oh, I can have a cookie if
You
I
have
want.
10 hours to go.
Look at all those cookies. I have one every half hour. I'll need the whole.
In this era of digital cameras and electronic light amplifiers, men are still watching the skies and craftsmen are still grinding telescope mirrors. Like this 21-foot monster under construction at the University of Arizona. But one thing hasn't changed much in 400 years. Astronomers are still battling their ancient enemy, the air. Starlight shimmers and twists as it passes through our atmosphere. The twinkling of the stars may be a delight to poets, but astronomers are trying to get rid of it.
What we can do is shine a laser into the sky. We focus on some sodium atoms, which are at about 100 kilometers above the surface of the Earth. We can make those glow with the laser and create an artificial star, which is sort of directly in line with the very faint object we want to look at. And then if we measure the blurring of the artificial star and correct that, then the faint object we really want to look at is corrected as well.
And we have liftoff. Liftoff of the Space Shuttle Endeavour.
But until that technique is perfected, astronomers have another way to take the twinkle out of the stars. All they have to do is put the telescope above that pesky atmosphere, in orbit. In 1990, NASA launched a space telescope and named it for Edwin Hubble. Unfortunately, its mirror was made wrong and its first pictures were blurred. Astronauts had to go up and fix it.
Houston, let's go fix this thing.
We copy.
Move it out of the sun a little bit.
We had a good aliveness test.
Outstanding. Houston, Endeavour has a firm handshake with Mr. Hubble's telescope.
We copy that, Cody, and there are miles galore down here.
It could be real exciting for the astronomical community, I guess, and for the whole world to see what Hubble really can do with a good set of eyeballs.
The out-of-focus pictures gave way to spectacular shots of interstellar dust clouds and the great galaxies of stars. In just one bit of the sky, a tiny patch that could be blocked by a grain of sand held at arm's length, astronomers found 2,000 galaxies. They were seeing better than they ever could before.
So one way of looking at it is if there was a firefly in Tokyo, and here we are in Washington looking at it, we could tell if there was another firefly 10 feet away. We'd actually be able to distinguish them.
In 1994, at the Space Telescope Science Institute in Baltimore, astronomer Wendy Friedman was using the newfound clarity of the Hubble to observe the heavens and stumbled into the cosmological controversy of the decade.
Yeah, I just wanted to ask you not to break out any observations until I give you a clear.
So when were these images taken?
She and her team, like Edwin Hubble before them, were looking at those milestone stars.
My cosmic rays aren't nearly as apparent. For our work, we need a telescope out in space because what we're after is a certain kind of star. It's called a Cepheid. And we have to be able to detect that kind of star against the background of a galaxy. In the Earth's atmosphere, smears and blurs our view, and we can't detect those stars.
Friedman got the best readings yet on Cepheids in a neighboring galaxy, and a measurement of its distance. Using the redshift speedometer, she calculated a new age for the universe.
Our preliminary measurements indicate that the age of the universe is somewhere in the range from 8 to 12 billion years, and that immediately brings about a conflict with other ages that have been measured.
That's a problem. Her universe is younger than some stars, and the age dating of stars is very accurate. Scientists can read a star's chemical changes like a clock.
When we look at a cluster of stars, hundreds or thousands, it doesn't really matter. What we have to do is go in and measure the brightness of the brightest star that's left in the cluster, that's still burning hydrogen in its core. And that star is the minute hand on the clock, because that's the star that is closest to burning out its hydrogen, closest to ending its life, and that's a direct measure of the age of the cluster.
But unfortunately, the star clock has been running 6 billion years longer than Friedman's universe.
But we're looking at globular star clusters, 100,000 to 1 million stars, and they're being age dated by several very reputable groups of physicists, astronomers, and they're all coming up with ages 17, 18.